Hi, everyone. Good morning, good evening, good afternoon. So, we are going through this series of understanding various foundational security protocols, security infrastructure, and we will go through string security as well. So, in this video, I think in the last video, we have covered digital signature. So, in this video, we will do a little bit of comparison between symmetric versus asymmetric cryptography. So, if you can see, I have three columns: characteristic is a feature, and then the next two columns are symmetric and asymmetric. How do they do in that characteristics? So first of all, keys. Symmetric uses one single key that needs to be shared, and then asymmetric uses two different keys, public and private. Performance: symmetric is very fast and efficient. Public key asymmetric is computationally more expensive. Common role in TLS encrypts application traffic, which are bigger, like your order, for example, credit card data, which are bigger. And then symmetric, what it does, authenticates and helps establish keys. So they are not exclusive. If you don't realize, please realize it now. They have a combined role in today's modern world. We join the best of both worlds. We realize that symmetric is extremely fast and asymmetric is extremely secure. So we bring both the characteristics. We use the symmetric keys in encrypting data fast. And then how do we ensure that the common key, which is the weak point of symmetric encryption, we use the asymmetric public-private key pair, which are not shared, extremely secure, to encrypt the key, not the data. And then during the handshake, when we exchange the key, we decide how do we exchange. The server encrypts the key using the server's private key and sends that to the browser, and the browser can easily obtain the server's public key. It can decrypt the encrypted key, which is small, in getting the key, and then when it will encrypt your order data, for example, it will use that key, which is shared in an encrypted form. The plain text key is not shared. So my purpose of saying all this is the symmetric encryption and asymmetric encryption placed together with their strong points in today's modern world. So these are typical examples: AES, GCM, CHA 20, Poly 1305, and then on the asymmetric sides, we have RSA, ECDSA, ECDAG, all this. Real life example is shared key to a locked room, and then public mailbox slot and the private key. That is a real life example I can give you. So let's go down a little bit. A common misconception. So does HTTPS mean the web application itself is secure? No. HTTPS protects network communication, authenticates the TLS endpoint, but if we keep the database password weak, a lot of people do, our application user ID password weak, then TLS cannot do much. So once some hackers through social engineering gets the actual password, TLS is not going to help because the malicious guy already has your password. It does not automatically fix SQL injection. There is an organization called OASIS. I forgot the full form. Open Web Application Security Project, if I'm not too wrong. That actually there is a OW OASIS Top 10 that keeps changing. So OASIS Top 10 gives you the latest top security vulnerabilities. Like 5 years ago, there was no AI in that. Today, there is an AI security, right? So let's see if we can open this private key contained in the certificate. No, the private key is not contained in the certificate. The certificate contains the public key and identity related metadata like your name, email, address, everything. The matching private key must remain protected separately. FX and PKCS hash 12 bundle may package certificate and private key together, but the X509 certificate itself does not expose the private key. This is the X509 certificate, is invented by IEEE. is the most common form of certificate that we use today. So let's see what is the next one. Does TLS use an asymmetric encryption for the entire web session? No. Public key cryptography authenticates the handshake and supports secure key establishment. That's all, because we need speed as well. The bulk HTTP traffic is often protected using efficient symmetric encryption. As I said, if we can use asymmetric encryption in protecting just the key, which is much smaller than the volumes of data that we send over the internet, that is very, very strong. We are not actually sending the plain text key over the wire. Is key cloak token signing certificate the same as HTTPS certificate? No. The HTTPS certificate authenticates the network endpoint and protects the TLS protection very low level. Key cloak is an application layer, OAuth2, for example, key cloak realm signing. Key signs durability tokens, so applications can validate token integrity and issue authenticity. Don't worry about it. We will go through durability, access token, ID token, and refresh token in detail. And then you will understand what are all these. Does automatic renewal remove the need for certificate monitoring? No, renewal can fail because of DNS changes, inaccessible validation endpoints. Again, cloud providers make this much more comfortable, missing permissions, unsupported network configurations, certificate authority restrictions, or unmanaged copies. Inventory, alerts, ownership, and expiration reporting are very, very critical. So let's see, these are the, if you can click on that, these are the standards and provided documentation. I included that for complete nets. They're very long, very hard to read. You don't need to go there. Just know the RFC request for change, I think, and then it'll be pretty good. All these AWS Certificate Manager, Azure App Service, Managed Certificate, Google Cloud, all three clouds provide automated certificate management. That is something your architect will know. So in the next video, what we want to do is we want to go through these architecture diagram that visually show handshake between the client browser and the web server. But that's for the next video. I don't want to prolong this video. Thanks for listening. As I said, this is a very foundational skill to learn security at the start. And if you have any question, please leave questions or in the comments area. I will try to answer your question as soon as possible. If you like it, please like, share, and subscribe. Press the bell icon. I will see you in the next video. I will get it.